Attendees are in listen-only mode.
Hello everyone, thank you for attending today's webcast, an introduction to Inventor's sheet metal environment. Today's presenter is Marvin Thomas, Solutions Engineer with Hagerman & Company. We also have Mark Dooley, a Solutions Engineer with Hagerman, on the line to assist with questions. This presentation is being broadcasted in a listen-only mode. You can ask questions by typing them into the question panel on the side of your screen, and Mark will be addressing those throughout the presentation. At the conclusion of the presentation, when you exit GoToMeeting, you'll be prompted to fill out a short 3-question survey. We ask that you take a few moments to provide us with your feedback. Lastly, all attendees will receive a certificate of attendance and a link to the recording of this presentation. Marvin, whenever you're ready, you may begin.
Good morning, ladies and gentlemen. My name is Marvin Thomas. As mentioned, I am the Solutions Engineer here at Hagerman. And today we're going to talk a little bit about sheet metal. So let's dive in. A little introduction. This is what's going to be involved in this presentation. A summary of what to come. We're going to do a little bit about sheet metal user interface for those that are not familiar with sheet metal. We're also going to do some of the sheet metal commands. Then we're going to go into documenting sheet metal as far as your IDW and applying that to a 2D form. This is basically an intro to sheet metal. This gives you a little insight of what sheet metal is and how it's used. So let's go ahead and begin. Before we jump into Inventor, let's talk about what is sheet metal. Sheet metal is a metal formed by industrial processes into thin, flat pieces. It is one of the fundamental forms used in metalworking, and it can be cut and bent into a variety of shapes. There are countless everyday uses and constructions for sheet metal as far as car bodies, airplane wings, air ducts, and roof buildings, as you can see there in the images. Sheet metal forming. There are a couple of sheet metal forming processes applied to sheet metal, such as curling, bending, punching, and more. Autodesk Inventor applies these processes with their sheet metal environment. As you can see in the images there, those are some of the sheet metal processes done, or forming processes done. The basic concept for sheet metal within Inventor is sheet metal, sorry about that. The basic processes within sheet metal starts off by, you would start off by defining the sheet metal rule, and then you would go into sketching your geometry as if you were creating a 3D part. And then from there, you use some of the sheet metal tools to create flanges or bends to your sheet metal product. And then you would go and create a flat pattern. And then from there, you would then create a 2D sketch of that model that you've created. Some of the common sheet metal terms that are used with Inventor is the K factor. The K factor represents the position of the neutral axis. There's the bend allowance. The bend allowance is the distance around the bend measured along the neutral axis. Developed flat length is calculated by using the formula, as you can see there, L1 plus L2 plus BA, which is the bend allowance, and that equals the flat pattern. The neutral axis is the axis passing through the sheet metal part. Generally in Inventor, it is assumed to be 0.44 of the thickness from the inside surface of the metal. The metal along the axis does not stretch or compress during bending. The neutral axis is something that is set in your settings prior to actually creating your sheet metal objects. The bend radius is considered to be the inner radius of the a bend, not the outer. And then the bend relief would be the area next to the bend where the material is removed to prevent stressing or tearing while bending. The flat pattern represents the sheet metal part before it is bent. The developed length is calculated according to the current bend allowance or K factor settings. Let's talk about the sheet metal atmosphere or environment within itself in Inventor. The sheet metal environment, you can either start as a standard IPT and convert that to sheet metal, or you can automatically start as a sheet metal object IPT. From there, you would go into the setup panel. As you can see here, we have the specific panels that are incorporated with sheet metal would be the sketch, the create, the modify, and then the setup. Those are the most important ones that are for the actual sheet metal environment. So let's talk about the setup panel. The setup panel is where you would go to set your metal defaults as far as what standards you want. And to create this flat pattern, you must consider the sheet metal defaults to develop standard bend allowance or K factor values. The sketch panel. The sketch panel is just like you would see if you were creating a 3D model as far as adding your sketches to a specific plane, and then from there you would extrude, or in this case you would add a face or a contour roll or a contour flange or a lofted flange, which we'll get into shortly. From there, you have your sketch, just as if you were creating a 3D model, and then you would go to your create panel. As you can see here, which we'll get into right after this, you'll see the first image shows 4 options as to, after you create your first initial sketch, the options that you can use. So there's the face, the contour flange, the lofted flange, and then the contour roll. Those 4 initial objects are the only 4 that you can use after you create your first sketch. Prior to using, after you use those 4 initial options, then you'll notice that those options that were grayed out are now available for you to actually, in essence, modify that first initial setup that you did for your sheet metal. Let's take a closer look. So now you'll see that I'm in Inventor. This is Professional 2015, and the setup is the same as if you were creating a 3D model. You would start off with a new, and then from there you would go to sheet metal. So I'd go to new, create new, and then I can go to either standard part, convert to sheet metal. I'll show you that just so that you guys can see that. Maybe I won't. We'll go to, we'll just go to sheet metal. I'll show you guys that after we go through the sheet metal part. So we start off from sheet metal, and then from sheet metal, the first object that we will do is we create a new sketch, like shown in the presentation. So from there, let's just create, we're going to create a face. So let's create a rectangle here. We'll make it 5 by 5. And you'll notice that it says fully constrained. So now I'm going to say finish sketch. Just go to home view. And then now I'm going to add, now you'll notice that these options here are grayed out like mentioned before, and then we'll go into actually creating that specific face. So now that I have my face, you'll notice that the options that are available here in this dialog box is the offset, so I can go either up or I can flip sides and go down. Sorry about that. Sheet metal defaults, before you actually start off your sketch, you need to set your sheet metal defaults. So if you go into sheet metal defaults, you'll notice that these are the default settings that are set for your specific sheet metal type. So you have settings as far as your material and then your unfold rule. If you actually select these pencils, means that you can actually go through and edit those specific features. So as soon as I select the pencil, you'll notice that it'll take me to the actual style and standard editor. Keep in mind that style and standard editor are designed to actually create your own rule, sheet metal rule, and then you can see that though right here it says read only, so you want to make sure that yours says read write if you're going to create a new sheet metal rule. Now you'll notice that I have default and then default millimeters. These are the ones that come standard with your Autodesk Inventor. If you wanted to create a new, you would actually go up here and say create new local style, and you would write in the name of your actual style. We'll keep it as copy of default. And then you'll notice that even though I created a new style, I still need to actually select that specific one by double-clicking, and you'll see that now that one is bolded. And then now I can go through here and actually change my default settings. So I can go through here and change my thickness. I can change my material. Say I wanted stainless steel. I can change my bend style. I can change, right now it says thickness, so that would be the thickness that was designated here under the thickness dimension. And then I can go through here and change my bending options as far as what I want that bending corner to look like as soon as I add that flange for flat pattern purposes. So excuse me when I said that you need to start off with a sketch. You usually need to start off with a sheet metal defaults if you want your specific default. And then from there, when you choose your sheet metal options, you can select your default setting that you have created. I'm going to put this back to default for this session. So now that I have my sheet metal defaults, if I wanted to actually create the one that I created, wanted to select that one, I can go through here and select my specific sheet metal defaults according to my company specs as far as the thickness that we're using, the bend factor that we're using, and whatnot. So now we'll go back into, we created our sketch, so now we're going to add a face feature to that specific sketch. So once I do that, you'll notice that my face feature thickness of 0.120 is now available. You'll notice that it's kind of like extruding an object, but it already has that thickness of that sheet metal, so you're not going through and adding dimensions as far as how thick you want that specific sheet to be. There's also these other options that are available. These always come up, but they're only applied when you have, say, for example, a bend. So you need that bend relief in there. So it would apply those rules that have been set in your sheet metal defaults prior to creating your first sketch. For in this case, we don't have any bends, so we don't have any unfold options or bend options. So now you'll notice that I have my first create object, which is my face. We're going to go ahead and create a new, we're going to go through the 4 options that we spoke about, which is the face, contour, flange, the contour roll, and the lofted. And then we'll go into adding other create features, and then we'll go back to modifying. So let's go through and create a new sheet metal object. And you'll notice that those 4 options, once again, because I created a new the part, you'll see that once again, those 4 options are the only ones that I can choose from. And the other ones are grayed out. So now let's do a contour flange. Oh, I need a sketch. So first, I'm going to start off with a sketch. And let's make a C channel. So let's start off here. Let's come out here and let's make it about 5. And then we'll go up and make this, let's make that 3. And then we'll make this one 3. We're keeping it very simple so that you guys can see how to actually use the objects and how each individual one are represented in sheet metal. So now that we have our dimensions in, let's go ahead and say Finish Sketch. And as you can see, I have an open sketch here, as opposed to if I were to make a face, I have the closed sketch. So now for my contour flange, if I highlight over it, you'll notice that it gives me a little detail as to what a contour flange is, just in case I didn't know, or if I wanted to go back and reference that. So once I select contour flange, it takes me to the dialog box that allows me to edit my contour flange. So I select my sketch, and you'll notice that it automatically, with the thickness that was applied in the sheet metal defaults, it automatically forms that contour flange. Right here, down here, it gives me the distance as far as how far up I want to go. So if I wanted to change that distance, for example, let's make that 10. I wanted to change that distance, you notice I can go back and forth between distances and actually change that specific distance. I can flip sides, and then I can make it go both directions. Unfold options, bend options, and corner options are always available, just like you saw in the face options, but are available when there's actually that particular object applied to my specific sheet metal object. Once I say apply, now I have my actual contour flange. Let's back up a little bit and go to actually the browser area. You'll notice that it populates just like as if I were to create a 3D part. You'll notice that my contour flange is now in here, and you'll notice that I have my sketch along with my bend area and then my corners. So if I select my bend, you'll notice if I double-click on that, it'll show me that specific bend area. I can go through there and say Edit Bends. Oh, there's no bends applied to this. So if it were a flange, for example, which we'll get into, it'll show you that you can actually go through here and edit those corners and bends. And the same thing goes to the face. It shows you my specific sketch that was applied to that face. Now that we talked about the face, we talked about the contour flange, let's go into the contour roll. So once again, we're going to go ahead and start a new sheet metal part. And then we're going to create a sketch for our contour roll. With the contour roll, it's similar to having a, similar to the revolve in the 3D model. So, for example, we're going to need to make a sketch. But I want to show you guys that, say, for example, let's make this visible so I have my revolved area. So say, for example, I wanted to make a circle. I have an enclosed circle, diameter of, let's make that 2. You'll notice, what I want you guys to notice is that if I were to select my contour roll, I can't select that specific circle because it's a closed surface. It's a closed sketch, excuse me. So if I were to go back in here and, actually let's just add a new sketch. If I were to go back in here and add, if I wanted to add a circle, what I would need to do is I would have to have a gap in that circle. I would have to have an open sketch so that that contour roll can form so that it can create a flat pattern, which we'll get into a little bit later. So once I add that sketch, it has an open area there. Now you'll see that I can select my specific sketch. Then I select my axis. And then now you'll notice that now I am able to actually do a contour roll about that point, about that line there. I can go through here and change the angle as far as how I want that to go around. And then I also have that gap go all the way through the specific sheet metal part. Okay, and the last one we're going to talk about is the actual lofted flange. The lofted flange is similar to having a loft in the 3D model here. The loft in the 3D model, but with the lofted flange, it gives you that hollow for ducting or anything like that. So first I'm going to have to start off with a new sketch. sketch here. We'll make that diameter of 2. And then in order, just like lofting, in order to have a loft, you have to have 2 separate sketches on 2 separate planes. So let's offset this plane here to be about 3 inches away. So now we're going to create a new sketch on this plane. Let's make a rectangle here. Let's make that 4, tab 4. So now that I have 2 sketches here, I can create a loft. So a lofted flange. So I'll select my first sketch. I'll select my second sketch. And now you'll notice that I have a lofted flange here. There's 2 output options. There's the die formed, and then there's the press brake. The press brake is usually used more often because if you're doing your sheet metal in-house, to flatten that sheet metal, you would need that press brake as far as your facet control. And to go along with that, there's 3 different options for your facet control. There's the chord tolerance, which shows you a little image there of what that means. There's the angle, the facet angle, and then there's the facet distance. If you change the dimension here, you'll notice that the angles will change, the distance will change for that specific one. And then there's the unfold options, which is always available. So you'll notice, what I want you guys to notice here too is that even though I have a lofted flange and I wanted to, say for example, which we'll get into a little bit later, but say for example I wanted to add a flat pattern, you'll notice that I cannot add a flat pattern in here. The reason being is that even though I have a sheet metal object, I don't have an opening for that to become a flat pattern. So what I'm going to have to add is a rip, which we'll get into when we go into modify, but I'll show you a little preview of what that means. So basically I'm going to have to add a flat surface. I'm going to select a flat surface and then select a point as which I want to rip that specific loft. So once I say apply, you'll notice that I have a cut within that area. So now when I go to flat pattern, it'll show me my flat pattern along with my folding options here. So those are the 4 types that you always begin with. So you either have the face, which is this first one that I created. You have the contour flange, which is the second one that I created, which starts off with an open sketch. Then you have a contour roll, which also needs an open sketch. And then you have a lofted flange, which needs 2 sketches, but they can be closed sketches. Now let's go back to the presentation. So now that we talked about actually creating your first initial model, let's talk about modifying the panel, the modify panel. The modify panel goes into actually creating different modifications to your specific sketch. So now let's go back to the actual Inventor. So now we have create and then we have modify. I like to dump flange, hem, bend, and fold into modify, even though it's not there, because essentially I feel like those are modifying features to your initial features. So once you create your, for example, my face, I can then go into creating a flange. So once I select my flange, you'll notice that my dialog box comes up. The flange is used to add bends to your specific face by selecting a specific edge. So once I select an edge, it automatically generates that flange and it automatically adds in that bend feature because of the fact that I added that default sheet metal default to that specific one. So let's add a couple bends in here just so that we can see an example here. So let's add a bend on all 4 corners. And then what you'll notice is that now I have bends and I have corners that I can go through and edit, which I'll show you there in a second here. So I can change the distance as far as how far up I want that bend to go. So I can change the distance to 4 inches, and you'll notice that now my sheet metal feature has a flange with a distance of 4. You can go through here and change your bend positions. We're not going to go too much into detail as far as the actual settings that you can go through here and change, but I'm going to kind of go through and tell you what they are. So then you can actually go through here and change your flange as far as what angles you want them to be. Say, for example, I wanted that to be a 45-degree angle as opposed to being a 90-degree angle, and you can see the difference there. And then you have your unfold options, which is preset in your sheet metal defaults, and then your bend options, which is also preset, but you can go through here and change, and then your corner trims. So if you wanted to have a different corner trim, this is where you would go through and actually change those. I suggest if you want to change your corners, then you would do it here while you preset or in your sheet metal defaults, because you'll notice, let's make that to default. You'll notice that now with my flange, if I go through here in corner, if I wanted to actually change my corner, I have to select each individual corner to change, as opposed to with the preset that it changed all the corners at the same time. And the same goes for my bends. So if I wanted to change my bends, I would have to change them individually as opposed to changing them all at the same time. Now that we talked about flange, let's talk about the hem. The hem option is what is used. It's just like the flange, but it adds that roll. So these are the 3 different types of, or the 4 different types of hems that are available. There's the single. Actually, let me put one in so that you can see. Let's select all the edges here. Actually, let's do this one edge for now. You'll see that there's a single. If I scroll through, let me rotate this so you get a better look. It shows you a preview of what each individual hem consists of. There's the teardrop, the roll, and then there's the double. And then there's also the bend and then the unfold options, just like you would see in either the flange or the face when you first apply those. You can rotate that so that it can go through the other side, and then you'll notice that there's the gap and then the length. The length is the thickness, which was defined in the sheet metal defaults of 0.120 times 4.0 or 4. And then there's the gap, which is the thickness times 0.5. And if you hover over that, you can see that the distances do appear as far as what that will be. Let's add a hem to this side just so that it can be unified. So now that I have a hem on both sides, I have a couple of flanges in here. Let's talk about the fold options here. For fold, basically, if I hover over this, it'll show me a short preview of what that means. Basically, for the fold, you need to have a sketch. So if I go through here and I create a sketch for my fold, so let's project this here. So let's create a sketch there. Let's put a distance on this. Let's make that 45. Add one here. Let's make that angle to be 45 also. And then let's make the distance between here and here to be, let's say, 3. And then the distance between here and here to also be 3. Make this distance, let's keep it that way. So now I can add a fold based off of those sketches. And if I rotate this object here, I can see a preview of what that fold will look like. And then it also gives me that bend radius of that fold. So now you can see that there's a fold on that specific edge there based off of the sketch that I designed there. There's also the bend radius. I can change the bend radius to fit my preference if I wanted that to be a different bend radius. Let's go ahead and cancel this. Let's share sketch so we can add another fold here. And then let's cancel that and let's change the visibility of that. So now I have a flange. I applied 2 hems to the side, and then I added a fold feature on this side. The bend feature is what's created as if I were to have, what you need is 2 separate faces. So let's create a face above this. So what I'm going to do here is I'm going to actually select a plane, offset that. Let's offset that at a distance of 10 inches. And then let's create a sketch on that specific plane. Because you need two separate sketches to create that specific bend so that those two can join. So let's just use that specific project area. So once I do that, now I'm able to connect these two by adding a bend feature. So if I select this edge and then I select this edge, you'll notice that it gives me a preview of what those joining two would be. And then once I say OK, you'll notice that now I have my bend that connected those two flat surfaces together. Notice that those two were perpendicular, so it connected those two flat surfaces together. So prior to that, after that, I would go through and actually modify different features as far as if I wanted to add cutouts, which we'll go through each one individually. So some of the key features that we're going to talk about, we talked about rip. Let's go into cut. So if I wanted to add a cut, the first thing I would have to do is actually have a sketch for that specific cut. One of the new features that was added in Inventor 2015 is the idea of with your cuts. So say I wanted to add a cut in here. Let's make that 1 inch. Let's make that. Let's move this. Let's move that about the center. Let's see. Actually, let's just move that for time's sake, just to the line. So let's say I wanted to add a cut in here. What I would do is I would add that cut, but you'll notice that it's across this bend here. So in 2015, what's been added is you can cut across a bend, and it'll give you a different feature. So you'll notice that when I cut it without doing across the bend, you'll notice that there's a little bit of a ramp in there. I don't know if you guys can see that. But if I were to do, for example, cut across bend, it gives me a complete circle, and it adjusts that specific, see, it cuts across the bend instead of cutting it short. So when I do go to flat pattern, which I'll show you in a little bit, is that it gives me a complete circle as opposed to the way that it was cutting without cutting across the bend. So that is one of the new features that's been added in 2015. After that, there's also the punch tool. The punch tool also needs a sketch. That's what that reminder was telling me. So if I go through here and I say new sketch on this surface, I can even add a point in here. Actually, let me project this area. And then let me add a point here. Wait till I get a dotted line so I can get the exact center point. So if I were to go ahead and select the punch tool, these are the punch tools that are available in the directory. These are preset punch tools. You can also set up your own punch tools with the eye feature in Inventor. So you can actually select, you can make an eye feature and drop that into your sheet metal punch tools. So one of the punch tools that we're going to select is the round emboss. So I can add that onto my area there, and then now you'll notice that my punch tool added that round in there, and then also caved in the inner portion of my sheet metal box here. There's also the hole option, which works similar to the 3D if you were designing a 3D part. So it gives you the same options, same dialog box that you see in Inventor 3D box. And then there's also the corner rule and then the chamfer rule. The corner rule, just like it's called, gives you corners. You can change the radius to what you want that to be. And then the chamfer rule would give you a chamfer. The corner chamfer would give you a chamfer to that specific corner edge. The last two things we're going to talk about in the modify panel is the actual unfold and refold method. So there's the unfold, which is kind of like the flat pattern, but not necessarily, meaning that you can actually unfold your object based off of a surface. So I select my reference surface. So this would be my reference surface, and then I select what bend area I want to unbend. So I want to unbend that area. So you'll notice it gives me a little preview of that. And once I say apply, you'll notice that everything else is still bent, but except for that specific area that I chose to unbend. And that is basically designed for if you wanted to make certain edits there, but you wanted just that portion as a flat surface, you can go through there and actually fold that area to add that. And then you can go back and say refold about that reference point, and then it'll change it back to the particular fold method that it was at. Now let's go back to the PowerPoint here. We talked about the modify. Now we'll go into the flat pattern, and then actually the flat pattern, how to create the flat pattern, and then what's available in Inventor 2015 is the idea of defining the A side. And then we'll go into the sheet metal drawing, which shows you how to actually add in that folded model along with the flat pattern. So now that I have an object that I created, a very fancy object here, I can go to adding a flat pattern to that. So once I say flat pattern, you'll notice that now I have a flat pattern. And as mentioned before, now for what's new in 2015 is the idea of cut through the bend. So now you have a complete circle. I know a lot of people have had problems with that in the past of that specific cutting option. So Inventor has supplied that with the new version. And then now you have all your bend areas as far as where those specific bends are going to be for manufacturing. You can also, if you select bend order, you can actually change the bend order and make sure that certain bends are done before others. and go back and forth between those. So that's pretty much the process of going through the sketch and then creating, going through, modifying, and you can go through and add patterns just like in an Inventor 3D model, and then you can go through and add work features. And then in flat pattern, you can also, these are the available options for flat pattern as far as if you wanted to actually extrude options, areas. One thing I did want to show you guys is, let's see, there's one that I wanted to show you guys, contour roll, I believe. For this contour roll, basically I wanted to show you guys is because that you can actually add different features to your specific model. So say, for example, I started off with a contour roll, or contour flange, sorry. And then I added a contour roll to that by creating a sketch here, and I revolved about this line here. So you can see the sketch there. I projected the sketch off of this first contour flange, and then I added that to my specific sheet metal object here. And then from there, I actually extruded a model based off of this flat surface. So what you'll notice is that I added a contour flange, I added a contour roll, and I also added extrusion. So you can convert back and forth between different styles as far as what you want that specific model to be. I talked about earlier converting back and forth between sheet metal objects and whatnot, and down here this is where you go to convert to a, say you want it to be back in a convert to a standard part. You can actually go through there and do that by selecting convert to standard part. Let's see, let's go back to here. So now that I have my flat pattern, I can go back and forth between flat pattern, and folded pattern. So now that I have that, let's go ahead and simply drop that into a standard IDW. Wait for that to come up. Okay. So I'm going to go ahead and change the sheet size so that it can fit. Edit sheet. Let's make that a size. So the first thing I'm going to do, you'll notice, is that my sheet metal view. So I can either drop it in as a folded model or a flat pattern. One thing I do want you guys to notice that is if it's already a flat pattern, the folded option will not appear. So you have to make sure that you keep that object folded so you can drop it in as a flat pattern. Oh, I'm going to need to save this. So I'll go ahead and save that, and I'll go back to my drawing. So I'll add in my base feature. Let's do a... Okay, let's do this view, a left view. So you'll notice that I can drop that in there. I can drop in my different views in there, and you'll notice that it's all folded, but then I can also drop in a flat pattern feature here. So once I drop that in there, if I have any room left, I can drop that in there, and you'll notice that I now have a flat pattern along with my folded pattern feature here. And then you can go through there and actually change those based off of what you want them to be, and along with adding dimensions and whatnot. That's basically what I have for you guys. I just wanted to show you guys the process of going through each individual one, and then show you guys how to actually apply that to a drawing. Any more questions do you guys have for us? I see that Mark has been answering a couple. Mark, do you have any questions that we need to address?
We've had a couple of good ones asked.
Okay.
One was when you add features to the flat pattern, you get a little message that says this will only be affected with the flat pattern, and that is correct. If you need to flatten the file to add features that would be there in the folded state, there's the unfold and refold commands that you would use to do that. So you unfold it, add your holes, your fillets, any of those things you need to do there that would need to be shown in the folded, but you need to do it in the flat for layout sake. Just use the unfold command, lay it flat, add your features, use the refold command to fold it back up, and you're good to go. And let's see, there's another one, and that is the corner round the same as the fillet command? Geometry-wise, yes. On the ribbon toolbar there even, just below the corner round is called the corner chamfer. It's same type of chamfer tool. It just limits out the options as to what you can do with it. So it's Autodesk, they kind of stripped out the command so that you can't do a tangent or a three-corner tangent type corner round fillet that you could do with a normal fillet or a G2 fillet. So they've kind of stripped out the command and just added it to the sheet metal environment. Let's see, there any more here? Got some more coming in. All right, there's one here. Marvin, can you show how to close up the corners of your model? Do you have a model there that you could show on closing up some corners?
Yeah, we can do that. Say, for example, if I have a, let's see, let's find a good one here. Let's remove these here, these folds. Remove that sketch. So say I have a corner here, and I want to, you can't necessarily close up, you can overlap those corners. So say, for example, I want to overlap those corners. I would select the corner seam option, and then I would select my corners as which I want to, and then there's the overlap, and then there's the reverse overlap. So those are the two options you have there for your corners. So you know that as soon as I do that, it shows me an example there, and then it'll show me the corner as how I want that specific corner to be. So I can either add a teardrop in there or a tear, and then I can say apply. And then once you see that, you'll notice that I have an overlap of that corner. Does that answer your question there? I don't know if you could see their questions. I can't see their questions.
Said yes, that answers the question. Thank you.
You're welcome. You're welcome. Any other questions? Okay, now I can see the question.
See, there's one here. Are the dimensions in the flat pattern compatible with CNC coding? I'm not sure what dimensions you would be talking about. As far as sketches and things like that added to the flat pattern, when you export this out as a DXF, all of those, the geometry goes with it. The dimensions would not go with it. That would be part of the G-code conversion process as it's being read into the device. But from a 2D side, if you add dimensions over into the 2D drawing and then export that out, or if your 2D file reads, or your CNC machine will read DWGs, then yes, the dimensions would carry over. So it's kind of two different areas there.
Okay.
What is the difference between cut across bend and cut normal? Can you pull that feature back up and show the difference between the two there, Marvin? Thank you, sir.
As you can see, if I were to, what was it, cut across bend and cut normal?
Yes, in the cut tool there.
Okay, so if, I don't think I could do it without, okay. So if you see, cut normal, when I add in that cut normal feature, you'll notice that it doesn't cut completely. It still has that angle in there. And then when I add my flat pattern, you'll notice that it gives that little gap in there. Cut across bin cuts completely across bin. Cut normal gives you as if you're cutting the circle, but it would be normal. So it would be normal to that specific surface. So it wouldn't cut all the way through as opposed to the way that the cut across bin would be. So cut across bin cuts all the way through, but cut normal would be on that specific surface. So it stops at a certain point.
Let's see, there's one here. Please show creating a custom stamp, puncher, emboss that can be reused for future. Kent, I don't know if we have time to go through that entire process here, but we could have someone contact you and set up a demo of that perhaps to walk through those features and kind of get a better understanding of what you would actually like to see. Let's see, some more coming in here. Can we show a semicircular rolled sheet? That could be performed with the contour flange. You can kind of draw out the radius there of your vessel.
Okay.
And then use the contour flange to kind of extend that and show the depth.
Let me go through that, actually. So they want to
Sure.
see
create a semicircular rolled sheet and then show the flatten of it.
an arc or something? Or something?
Yeah, perfect. Yep, throw you an arc on there and use the contour flange to show the shape and the depth of it. And then to change the thickness, change the rule, and so forth like that.
Okay. So you can go through and change the thickness. I would add a contour rule here. I have my and then add the add it around about that axis. I can go through and change my thickness in my sheet metal default rule. Use thickness, or I can change the thickness here.
Let's see, how do you add ribs or gussets to an L bracket? Well, that would be more of an assembly feature. If you were adding in, unless it was going to be machined down, which in that case wouldn't be a folded sheet metal part. It'd be a standard part that you could put those in. But to add ribs or gussets to a sheet metal, that would be another piece of plate being put in, welded in, or shown in, so that would be done in the assembly environment. Back to the cut normal you did, there's a question, can that cut extend through the next surface or through all? And the answer is yes, that can be done. Where it says, where it's showing thickness there in the dialog box, you can change the pull down to all, and it will cut that through everything, just like a regular extrusion would.
Okay. Yeah, sorry about that. I answered that, but I think I answered it as a direct message, so it didn't come up.
No problem. Thank you, sir.
Thank you.
Here's a question, is there a way to show the model in a drawing with only certain bends? In other words, could I do a drawing showing the step-by-step bend process? Possibly that can be created with the part-to-view representations. I'd have to do a little testing there to verify that. I don't want to say no because I think it can be done. It would just take some testing there. Let's see. You could contact our service department and we could set up a support step for that and kind of walk you through the process there. Alright, let's see. Any more questions coming in? Is there a punched feature? Yes, I think you showed those. Alright, there's a question. Let's see. Do people use this for non-sheet metal applications as to draw a sculpture, not of sheet metal? Not sure about a sculpture, but cardboard box manufacturers use the program for that to show the size of their boxes and folding it together and so forth and seeing where the interferences are going to come and how much material it would take to size that box. So it is used for non-sheet metal applications there.
And these are some of the applications or the materials that you can actually select from. So there's plastic, aluminum, copper, glass. I mean, there's all types of materials that you can actually go through here and select when you're setting up your sheet metal defaults.
Alright, so assuming I had a stock gauge of sheet metal that was used often, is there a way to set up a standard template for that certain material? Absolutely. If you start a new sheet metal file, adjust the rules, set it like you want, and then do a save as template, or open the standard template and go into the sheet metal edits and add your own thicknesses and so forth, and then save it. Absolutely, you can save that as a template or save the template itself to have your custom thicknesses ready to go. Is there a way to get a flat pattern at the mid-plane of a part? The flat pattern is going to come from one of the faces of the part, not of a plane such. But with Inventor 2015, you can define the A-side flat, so you can tell it which face to flatten around. All right. See, there might be one or two more here. Is there a punch feature to create a stiffener in the L bracket? Again, you'd be leaving the sheet metal application and adding a feature that would have to be machined down if it was one solid, or added as a separate part for welded into placement. And here's one. Can you redefine the K factor? Can you pull up the sheet metal rule and show them where they can edit the K factor there?
Sure. So you go to sheet metal default rules. K factor. Oh,
Back to your sheet tab.
sheet tab.
There you go. Unfold rule on the right.
Oh, unfold here. You can
Yep.
actually go through here and define your K factor value. Do you have any more questions?
Is there... Let's see here, rolling through them. Is there a method to creating the flat pattern when there are embossed areas without deleting the feature? It's not sure exactly what you're asking there. If you go into the flat pattern and add the punches or embosses, they will only exist in the flat pattern. However, if you do use the unfold command to flatten the folded model, or to put the folded model in a flat state, not the flat pattern, then you can add those there and they will still be there in the folded environment. I'm not sure if I'm answering that correctly. I may not be understanding the question correctly there. But if you add it to the flat pattern, it will only exist in the flat environment. But if you need it to be in the folded area, then you would just use the unfold and the refold commands. Must the added rip be placed on a fold? No. The rip can be across a face at a center point, or if you've got sketch points put in somewhere indicating it, you can apply the rip along those points as well. Can a simple cut enable a testy flat pattern? It's going to depend more on the geometry and where you're placing the cut at as to whether it would satisfy the desire in the flat pattern or not.
All right, we're coming to the end of time here. Any unanswered questions can be answered offline. So we're going to go ahead and end this session here. Thanks again for everybody that participated. If you have any further question, you can contact us. And if you're interested in maybe taking a class or interested in the software, you can contact your manager. Thanks again, everybody, for joining. You have a great day.